Welcome to Tech Teach.
So the next point, that is the registers in the computer system. So what are the different register organization is there? So into the computer system, we see like the CPU or the processor is having the control unit. So processor, so microprocessor is basically having ALU, control unit, and registers. So what are these registers are there? How many registers are there? That we will be going to study here. We know registers is a very fastest computer memory used to store data or instruction in execution. So if anything is being executed, to temporarily store the data or the programs or the instructions, we basically use the registers. So registers is made up of different group of flip-flops. So group of flip-flops is the register. Okay. And we know flip-flops is going to store 1 bit of information. If n bit register is there, that means it will be having n number of flip-flops. There are different types of flip-flops. So which flip-flop we should be using based on the advantage and disadvantage of the flip-flops itself. So you can think of like any flip-flop is there that is most frequently used, like D flip-flop or T flip-flop or JK flip-flop. If we are using n flip-flops, we will be able to have n bit register. So one, you can think of like generally if 8-bit processor is there, so its register size is basically of 8-bit. So 8-bit in the sense it will be able to store the 8-bit of data. So it is having an 8-bit register. Similarly, 32-bit processor is there, so maximum size of the registers will be 32-bit. If we combine two registers, we can have the 64-bit combination. Likewise, there are different capabilities based on the different type of processors. In the registers, there is a term like register transfer language. So register transfer language is the language in which we represent the data transfer between the registers. Is like if it is given, if we are that is just like a representation, how we are basically representing the transfer of information. So if we are going to do like we are having R2, we are going to store the value like R1, we are adding with the R2. So the register R1 data is added with the register R2 data, and the result is stored into the R2. So this is how we basically write the representation of the data for different registers. So this representation is basically called the register transfer line. So the symbolic notation used to describe the micro operation transfers among registers is called register transfer language. So this is a representation of the content of registers in a register transfer language. So how the content of registers are being changing between registers is basically represented by register transfer language. The term register transfer means the availability of hardware logic circuits that can perform a stated micro operation and transfer the result of the operation to the same or another register. So register transfer. So this is the register transfer. Means the value of R1 is added with the R2 and the result is stored into the R2 itself. So this is called register transfer. And the representation of this is basically called the register transfer language. Yeah, the same. The language is just like a representation, how we are representing the things. Into the computer system, there are following commonly used registers are there. So any computer processor is there. So in that, these are the different registers that are basically used. There are other registers also, but for most frequently used registers, we will be considering this only. So accumulator is one of the registers. Then there are different general purpose registers. So general purpose registers are the group of registers. There are like in some processors, it will be having 6 registers. In some are having 12 registers, 10 registers, 15 registers, called general purpose registers. Accumulator is the register. This is the most common register used to store the data taken out from the memory. In sense, if any data we are going to store from the memory, and if the processor is going to access the data from the memory or do some operation on the memory data, then it will be fetching the data from the memory and put it into the accumulator. And then another data, suppose we are adding. So we are adding the data, suppose an instruction is there add. R1, comma 5. If this is the case, suppose this is the case, or we are adding the data content of R1. So R1 is the data. Then we are going to add with the 5. If this is the representation, or if the representation is put the data. So this 5 is there. This is one instruction. Another one is we are going to add accumulator A, comma R1. Here in the A, we are going to move the data. So we are going to add like move A, comma 5. So 5 we are moving to A, then A and R1 is added. So likewise, so once we are going to do any operation, we will be temporarily storing some data into the accumulator, and the result after putting the data into accumulator, we will be adding it. After performing the operation, the result will also be stored into the accumulator. So accumulator is one of the important register that is basically used to store the temporarily store the result of the any operation. If any ALU operation is being performed, so its result will be generally stored into the accumulator. That is by default. General purpose registers. This is used to store data intermediate results during program execution. So during program executions, for temporary storage of the data, we will be using general purpose registers that can be used for different operations. It is general purpose, so it can be used for different purposes. While having the operations, while having the execution of the instructions, we'll be using these general purpose registers. So there are different types of general purpose registers that can be named like R0, R1, R2, R3, R4. Likewise, there are different types of different numbers. So these number depends based on the processor. If the processor is 8085, it is having the general purpose registers named A, B, C, D, E. Okay, A is not, it's like A is accumulator. So it is B, C, D, E, and HL. So these are the general purpose registers that are there into 8085. Similarly, if 8086 is there, so it is having this. Along with that, there are some extra general purpose registers are there. So based on the processor, what processor we are talking about, so there will be different name of these general purpose registers. There are some special purpose registers. So what is the special purpose register? At the name suggests, it will be special purpose. So its use will be done only for special occasions only. So here user do not access these registers. So one of the important parameters to differentiate between general and special purpose. General purpose can be used, can be accessed via assembly program by the user. User can access these general purpose registers, but the special purpose registers is not available for user. These registers, special purpose registers, can be used only by the computer or by the processor. Microprocessor will only be able to access these special purpose registers. One of that is MAR, that is called memory address register. So memory address registers are those registers that holds the address for memory unit. In the sense, if you want to access data from a memory, so we have seen the previous example. If a memory is there, we want to access the data from this address. Suppose address is 0502 is the address. At this address, whatever is the data, you need to fetch. So how the processor or the system will be understanding like which memory location we need to go. So if we want to go to 0502 memory location to access the data, that is data is D, then this address 0502 will be put into MAR first. Once the address is put into MAR, that is memory address register, its meaning is whatever is the data into MAR, that will be indicating like the processor needs to go to that memory location, and whatever is the data that needs to be put out on the data bus. Okay, so this is the role of memory address register. Okay, similarly is memory buffer register. So memory buffer register stores instruction and the data received from the memory and sent from the memory. In the sense, if MAR will be storing the address, and after this address going to this address, this D is the data. Then this D data, this will be stored on MAR, and this data will be stored on now the MBR. So MBR will be the register that will be temporarily storing the data onto MBR, and then it will be given to the processor basically. So this is the basic idea of MAR and MBR. Next one is program counter. So program counter points to the next instruction to be executed. So whatever is the next instruction, so suppose there are different different instructions. Suppose this instruction is executed. So next instruction is this one. So for this instruction, where this instruction is stored into the memory, so it will be storing. Program counter will be storing points to the next instruction address, storing the next instruction address that to be executed. So whatever this is the instruction, if its address is this, so this address will be stored to the PC, that is program counter. So program counter will be, its role is only to store the address of next instruction that needs to be executed. IR is instruction register, that is it holds the instruction to be executed. In the sense, if this instruction is executed, needs to be executed, its address will be given by the program counter, but once it is executed, it needs to be executed, it is stored in the form of code. It is having a code. So this code that is called basically the opcode, or it's opcode. It's called opcode. So this opcode is a value that will be stored into the instruction register. Okay, so address of the instruction will be given by the program counter. When the data of this instruction, that is code, that needs to be fetched by the processor, it will be stored into the IR register, instruction register. If it is stored into the instruction register, that value will be reaching to the processor. There are some other registers are also there, like stack pointer, that is stack pointer is another register. So into a memory, some portion of the memory is considered to be the stack memory. So stack memory, there is a memory that is having the capability of last in, first out. Okay, it's like the glass. So whatever the data we have put into there, whatever the last data is there, that will be coming out first. So whatever is the last data that is put here, so what is the address of that last data is basically indicated by the stack pointer. So stack pointer is a pointer that indicate the top of the stack, top of the filled stack. Similarly, there are some other registers are also there. We will be looking it out once we will be coming later on in this course. Yeah, register transfer, as we see. So register transfer is like information transferred from one register to another is designed by the symbolic form. So if it is placed like R1, there is an arrow to R2. Its meaning is data is being copied from R1 to R2. So it is transfer of data from register R1 to R2. Normally, we want to transfer to occur only in predetermined control conditions. So we want to transfer the data only when there is some condition that is satisfied. That means it is like if this is satisfied, then do this. So that is basically done by the control function. So control function is like there will be a function P. If this P is high or it is true, then only this transfer will be taking place. So this is like a control function is a Boolean variable that is equal to either 0 or 1. If it is 1, this will be activated. If it is 0, means this will not be done. So the control condition is terminated with a colon. It shows that transfer operation can be executed only if P is equals to 1. If this P is the condition, if this control function is true, then only this transfer will be taking place. So transfer is basically represented in terms of arrow, or it is like, as we have already seen, like if it is R2 given by R1 plus R2, it's meaning R2 plus R1 will be added and its value, addition value will be stored into R2. So this is indicating the transfer. So this is called register transfer. Register transfer language, this representation is register transfer language.